Well, we've got Timothy W. Young on the line, who was a high school principal and mathematics teacher for almost 38 years. And we're going to talk about his textbook, 1, the most powerful number. How are you doing today?
I'm doing very well.
Great. So why do you think 1 is such a powerful number?
That's a great question. I wrote a book. The textbook is about 600 pages, explaining a lot of the tricks, I'm going to say rules that are involve the number 1. For instance, the only way you can convert from one unit of measurement, such as, make it simple, 36 inches to feet. Most people think, you divide by 3 because that gives you, 36 inches, you divide by 12 and that gives you the answer 3. But that does not explain why the 36 inches, and I emphasize the label inches, changes to 3 feet. The only way you can realistically convert 36 inches to 3 feet is multiplied by a ratio which equals 1. So that the units cancel, and you would have 36 inches times 1, but 1 would be 1 foot over 12 inches. And inches is in the denominator. It's the only way you can convert anything from feet to inches, miles to feet, time, minutes to hours is technically to multiply by a ratio equal to 1. And that's a real concept that is not emphasized by many teachers because they don't think about it. Because it's this concept they don't realize that there's a ratio equal to 1 that doesn't look like 1. And it can be 36 inches over 1 foot, 36 inches over 3 feet, or 3 feet over 36 inches. And these are all ratios that equal 1. And it actually becomes very important in higher level mathematics, and it becomes very important in physics and science. So 1's a powerful number there. But that's just one example.
It makes sense because maybe this goes without saying, but it is the basic number to which all other numbers and sums are based upon.
Right. The other thing is, how do you convert the fraction 3/4 to 6/8? They're equal. There's only one way to convert 3/4 to 6/8, and that's to multiply by 2 over 2. What does 2 over 2 equal?
1.
1. So 3/4 to 6/8, you multiply by 1, but 1 is 2 over 2. You can do that with any fraction. There's an infinite amount of ways to multiply any fraction to find equivalent fraction. Go with 5 over 10, multiply it by 5 over 5. 5 over 5 is 1. So that's the simplest, and you can start that particular concept in 3rd or 4th grade by multiplying by 1 to find an equivalent fraction. Or when you get into units, you can change units by multiplying by a ratio equal to 1. And very, very few teachers even know that concept, especially in elementary school. And very few teachers emphasize it even in middle school.
So why did you decide to write this book?
That was something that's been on my mind for probably the last 10 years I was in public education. I was a high school principal, and I was a principal at 2 schools. One was in central Pennsylvania near Penn State, and one was located right 10 minutes from downtown Pittsburgh called Chartiers Valley. I used to get phone calls from parents every year. And in Chartiers Valley had about 1,100 students. And I would get parents calling, and they would complain about teachers. Nothing unusual, except I noticed most of my parent complaints were about the high school math teachers. And they would make comments that the teacher doesn't teach, the teacher doesn't explain. And I knew in my mind that it didn't start when that student entered Algebra 1 in 9th grade. I knew in my mind it probably started earlier, but I had to be careful how I responded to a parent because I could never make a comment, well, the teacher below didn't emphasize things. I would make the comment, your son or daughter who always got good grades in arithmetic, they probably have some gaps and their arithmetic understanding. And those gaps become magnified when you go into algebra. So when I retired, I got involved with a professor down at Carnegie Mellon University. Yeah. And there was an article in the Pittsburgh Post-Gazette about this professor, and he found the secret to understanding math. And it concentrated on fractions. Fractions is the number one indicator of success for kids in fifth grade if they're going to be successful in algebra.
Yeah.
And the first example, the one example I gave you was the fraction 2/3, 3/4, any fraction. You can convert it into equivalent fractions by multiplying by 1. So for all those parent complaints, I wanted to tell them that the problem started with your son or daughter in fifth or sixth grade, but now they're magnified in Algebra 1. But I was very careful because I could not say something negative about the elementary teachers, who I usually think do a fantastic job. But I also had to protect my high school teachers. So I would make that comment about there's probably some gaps. And now they're magnified in algebra. But a lot of the problems started with fractions in fifth grade and not understanding how to apply the number 1 to find equivalent fractions.
Yeah, 4 out of 3 people have trouble with fractions. And I remember back at school, that was the thing that everybody struggled with. But it's not really that hard. People just get overwhelmed by it somehow, don't they?
I think that's well spoken, Toby. I ask, I'll give you an example in a research paper. Multiply 3/4 times 1/2. Well, before you answer that, if you multiply 6 times 7, the answer always gets bigger.
Yeah.
But a professor named Dr. Hugo Lorte-Forges, who's now in Great Britain, who I worked with down at Carnegie Mellon, asked that question 3/4 times 1/2 to college graduates. And the answer actually gets smaller. But around 50% of college graduates said, well, it has to get bigger because anytime you multiply, it gets bigger. That's not true. If both fractions are between 0 and 1, the answer gets smaller. Think about it. If I say find 1/2 of 3/4, that's the same problem, just said in another way. Half of 3/4 gets smaller. But when you see it written as arithmetic problem, 3/4 times 1/2, around 50% of college graduates thought it got bigger. That's college graduates.
Yeah, that's quite remarkable, isn't it? I think maybe they weren't thinking about the question properly because, it is like 0.5 times 0.5. Would of course be like 0.25, whereas a fraction, you just see it as pure numbers, so it messes with your head a bit.
He did the same research as a follow-up with decimals between 0 and 1 and got the same results.
Oh, really?
50% of college graduates had trouble with decimals when you multiply between 0 and 1.
That's interesting.
By the way, interesting, if you divide two fractions between 0 and 1, 3/4 divided by 1/2, the answer gets bigger.
Yeah.
And that was there were 4 questions. One time you added 2 fractions. One time you subtracted 2 fractions between 0 and 1. Then you multiplied them and then you divide them. And 50% of the college, I think it was 47% of college graduates missed the multiplication and division problem. 3/4 times 1/2 and 3/4 divided by 1/2.
That's true, isn't it? Sometimes there's these posts on social media, mainly trying to catch people out that don't know about BODMAS. But there was one earlier today I saw, which was like 40 divided by 1/2. And a lot of people forget that divided by 1/2 basically just means to double it.
Right. I know. I don't, there's no course that we have in elementary school, high school, that teaches what I will refer to as number sets.
Yeah.
And that is a topic that is so important that I think most teachers, every time they get the opportunity, need to explain number sets to kids. And I don't think teachers even think about it. And this is the kind of problem I'd be talking about, which we just discussed.
Yeah.
3/4 times 1 is number. Now, if you have 3 3/4 times 6 and 1/2, they're both greater than 1. The answer does get bigger. But when the fractions are between 0 and 1, when you multiply, they get smaller. But and by the way, I'll give you another thing. The second biggest indicator of success, according to Dr. Sigler's research, and by the way, Dr. Sigler was at Carnegie Mellon for 40 years. So he's not a youngster anymore. And then he retired from Carnegie Mellon University, takes the same type of job at the Teachers College at Columbia University. He's still there doing research on math education. And I talk to him maybe once a month or email him. About 3 weeks ago, we emailed about 10 times back and forth about the frustration with this kind of thing. But the same, he did a lot of research initially on number lines, getting kids in kindergarten to place the points on the line between 0 and 10. But in kindergarten, kids overestimate how big 4 is. And then in 3rd grade, he did it with fractions, trying to get them to place fractions on a number line, just to get them to have some understanding, some sense of how big 3/4 is compared to 7/8, compared to 1/3. And number lines is a great way to get number sets for fractions.
That's actually quite a good idea, because it is difficult to imagine 3/4 and 7/8 on a line together. You have to think, right, 3/4 will be 3/4 of the way up and all that.
So in my book, I address those topics such as number lines early in my childhood, starting in kindergarten with whole numbers, starting in late second, third grade with fractions. And then I got into the number lines with even weird fractions. Put them on the number line when you have something like 7/8 times 3/4. Plot both points on a number line and then plot the answer, which is a product on the number line. And you say, whoa, that answer is smaller than either one of the fractions I start with.
Yeah.
If 3/4 plus 1/2, the answer gets bigger. So I tried to have the kids do number lines where they plotted all 3 points, whether they were adding two fractions and getting an add end, or they were multiplying two fractions and getting a product, just so they could get some understanding on magnitude and number sense.
So how does this textbook help students? Does it help them be able to do certain equations and questions in areas that they were struggling in?
The textbook is actually written for students still in college that are going or preparing to be elementary arithmetic teachers and secondary math teachers. It's helping them understand how to do these problems. And then I give them suggestions how they can teach so the students will learn. For one, I illustrate and emphasize how to use rules to solve challenging problems after you have emphasized concepts. You got to do concepts, but if that's all you do, there's a lot more to arithmetic and math than just concepts. Emphasize minor concepts. Students assume students understand, but in reality, they don't. Show students how to use present topics to solve future math problems, but here's the two key ones. Introduce topics 2 to 3 months at a time for 2 or 3 minutes, 3 times a week. And you'll find when the kids get to actually solving arithmetic problems, fractions, they've been doing it for 2 months, and give them fractions like 1/8 plus 5/8. And they can come up with the answer, 3/5 plus 1/5. You start introducing them 2 months ahead of time for 2 or 3 minutes. So you have to take 2 or 3 minutes out of a couple of classes. But you'll find in the end, the kids have spent 2 months redoing these problems. And by the time they get to it, these problems, they find the textbook problems the first time. The textbook problems they find simple and they can do without much help.
So what was it that got you into maths originally? Because at school it was everyone's least favourite subject.
I actually smile when you ask that. When I was a senior in high school, I went to a high school and our graduating class was about 1,000 students. My last name being Young, I was in alphabetical order, 969. So I don't know exactly if there was 1,000. But I went into the guidance counselor who had all 1,000 students. And he said, Tim, what are you going to do? And I said, well, I'm accepted at both Penn State and Indiana University of Pennsylvania. And what do you want to do? I want to be a math teacher. I knew how to be a math teacher because I was good in math in high school. And he looked at me and said, yeah, you are good in math. Why don't you go to Indiana University of Pennsylvania? They have a better reputation for education than Penn State did at that time. I'm not going to say what they are now because I love both schools. But that's how I ended up getting into math, because my guidance counselor, in a 10-minute conversation, because he didn't have time to sit down and go into details, said, you are good at math. Why don't you go into math education? So that's what I did. But I've always had fun in math. And I always had a dream that every year I was better than I was the previous year. I would sit down in the summer and evaluate what I could do better next year that I didn't do as well at last year. So I always wanted to get better. I never reached my goal of becoming the best, but I always tried to get better. And I think I succeeded at that.
How do you become better?
I'll give you, every summer I would like a topic. I would look at the subjects I'm going to teach next year. And I would write down the 5 most important things I want the students to know at the end of the year. And I'll pick algebra because that's my favorite subject. And one of the key things in algebra is quadratic formulas. You don't teach quadratic formula in 2 days. You don't teach it in a week. That's a topic if we got to it in February 1st, I started introducing how to work with the quadratic formula and develop it, how it was used on November 1st for 2 minutes, 3 minutes a day, 2 or 3 times a week. So by the time the kids got to February 1st and they had quadratic formula questions, they knew the formula. They knew how to work with it. And you can't, we have a habit in math of giving them a difficult topic and try to teach it in 3 or 4 days. And we wonder why students struggle. You can't do that with difficult topics, especially in advanced math, such as quadratic formula. And then logarithm is another one that I love to teach, but I didn't teach that in 1 day. I taught it over 2 or 3 months. So you've got to spread out. I have a theory that the longer time you spend talking about a topic, and I'm not talking 1 hour here, 1 hour, I'm talking over a period of 3 months. The longer you spread out the introduction, the easier the topic is to solve the problems once you get to that topic in the textbook, and the more prepared the students will be because they've been thinking about it for 2 months without much pressure, because it's an introductory topic where you're not giving them a test on it.
That's true. I think a lot of people did struggle when I was at school with quadratic formula and logarithms, but they're both things that once you get your head around them, you'll find them pretty easy.
Yeah, I used to on purposely not write up midterms and final tests, and I would allow some other teachers to write it up. And I'll just give you one. There's about 2004, 2 other teachers wrote up the geometry final. And my kids came back after taking the final, and they said that was the easiest test they ever took, because I had reviewed, not only do I introduce, but I had reviewed it 2 or 3 times a week after I taught a topic. And the kids came back, and I had out of 44 students, I think I had 36 A's, 5 B's, and 1 C.
Wow.
Joked how easy the test was. I didn't write the test. I didn't tell the other teachers how to write the test. I said, write it based on the course curriculum and the topics we're supposed to teach. But my kids, because they had introduced the topics over a period of 2 months and then reviewed for a month or 2, I didn't have to spend time at the end of the semester, end of the year, trying to review all the topics. They knew how to do them.
Yeah.
I mentioned this because it was fun being a math teacher when the kids knew how to do the problems and felt confident solving the problems. It made my life enjoyable.
Yeah. Well, have you got any more books or textbooks that you're working on at the moment?
Well, yes. This book, the first book, the one we're talking about, is designed for students in college as a 3-credit course for college professors to use to help students prepare to be elementary teachers, secondary math. And it's full of 1,000 different questions that I expect them to explain how to, for instance, explain what a prime number is. How do you explain that to a student? But it's full of about 1,000 questions, of course, 10 different assignments. The other book that I'm working on is really a book for experienced teachers, and it's not a textbook. It's more of a book you sit down and read for enrichment. They're very similar. The one's more of a textbook with 1,000 math questions for students in college to answer. The other book is more of an enrichment book for if you're presently a teacher, elementary arithmetic teacher or secondary math teacher. One of my editors looked at it, and he's an English teacher who just retired. And he looked, and I said to him after he was editing it, I said, it was named Steve Everhart. I said, Steve, did I write the explanations and the problems so that anybody, such as an English major or an elementary major, could understand the procedures that I indicated? And he said, his comment was, Tim, the only way they could not understand how to solve the problems based on the way you explained it is if they didn't care and read it. That was an English teacher reading it he's been published many places, but mostly by a ghost name. But his name's Steve Everhart, and he's from Tyrone, believe it or not. When he was in 9th grade, Penn State tested him and said, he's one of the best we ever tested as writer in 9th grade. So I've known him for 48 years.
Well, where are we able to find this textbook, 1, The Most Powerful Number?
It will be posted on Amazon probably sometime. The ISBN number has been assigned, and we're doing the final drafts of this, and I hope we have the final draft in place within the next 10 days, 2 weeks. I actually spent a week and a half going back and doing all 1,000 math problems about 2 weeks ago. And I found 3 errors. But 2 of them were typing errors, and one of them I forgot to go 4 times 4 is 16. So because it's so easy to make a mistake when you're doing a math problem. But out of the 1,000 problems, I only found 3 errors, and 2 of them were typing errors. So I'm hoping it's ready on Amazon by mid-December. The ISBN's been given, and now we're in the final drafts.
Well, many thanks for talking to us today. It's been great to have you on the show.
Thank you so much. I enjoyed it. Take care, Toby.